hopefully these videos are working okay and you guys made it through yesterday. Today we are going to be learning about work problems. So let's look at, this is the second part of our objectives for this section, is using fractional equations to solve work problems. So yeah, let's get started. So this is a formula that I would love for you guys to all write down. It's going to be just that the work rate times the time equals the work done. And the work rate, that's just the fraction of the job that can be done in a unit of time. So remember, when we say unit, we just mean one. So it's how much you can get done per minute or per hour or per day, something that's just one unit of time. So let's look at our first example. It says that Winston can paint a house in 4 days and Ferguson can paint the same house in 6 days. So how long would it take them to paint it if they work together? So I'm going to go ahead and figure out what my variables are going to be. So let's set D equal to the number of days required to do the job together. So our unit variable here is going to be 1 day. So since Winston can paint the house in 4 days, he can do a quarter of the job in 1 day. So right, if he takes him 4 days to do one whole thing, then if we take the reciprocal, we get that he can do a quarter in 1 day. So then in D days, he can do 1/4 times D of the job, which is just D over 4 of the job, if we simplify that fraction there. And then similarly, we can set up a fraction for Ferguson, but instead of having 4 in the denominator, we're going to have a 6. So he can do D sixth of the job in D days. So now that we have this set up, we know that the amount Winston does plus the amount Ferguson does is going to equal the total, right? It's going to be the whole house. So this is our equation now. We have D over 4 plus D over 6 is equal to 1 whole job. And now it's pretty easy because we've got our numerators already up, our variables are in the numerator. So for our denominator, our LCD is just going to be 12, if we've got a 4 and a 6 there. So I'm going to go ahead, and I apologize, my spacing's kind of weird, but we're going to have 12 times the quantity D over 4 plus D over 6 is equal to just 12 times 1. So when we cross cancel our numbers there, we end up with 3D plus 2D on the left is equal to 12 times 1, which is just 12. So now we can combine those on the left-hand side. We get 5D equals 12, or D equals 12/5, which we can rewrite as 2.4. And so our answer is that it would take them 2.4 days to paint the house if they work together at these rates. So pretty simple first example here, I hope. Let's go ahead and move on. And if you guys, again, hopefully after that first video, you got good at pressing that pause button whenever you needed to. So again, feel free to stop these videos if I'm speeding through them. I'm trying to do a few of these tonight, so I apologize if I'm going kind of fast. So for example 2, we have that Jess can mow the lawn in 5 hours, but it takes Nick only 3 hours. How long would it take them to mow the lawn if they work together using 2 mowers? I feel like if I was here, Sean would have picked up on them sharing a mower, so they've got to add that caveat there. So if you guys want to just work on this one for a minute, and then we'll go through the answers. So I chose to use H for my variable this time since we're talking about hours. And so if H is the number of hours required to do the job together, then, and we know that Jess can do the whole lawn in 5 hours. So to switch that over to the units, we just take the reciprocal of 5 and we end up with that she can do 1/5 of the job in 1 hour. So then in H hours, she can do H fifths. And similarly, then Nick can do H thirds of the whole job in H hours. And again, we know that when we take the sum of H over 5 and H over 3, it's going to equal to 1 because that's our whole project here, the whole lawn. And again, we've got all of our variables up in the numerator. So for our LCD, we're just going to get, let's see, 15. So if we cross cancel that out, we end up with 3H plus 5H is equal to 15. We can combine those on the left-hand side to get 8H equals 15, or H equals 15/8, which if you pull out your calculator, you're going to find is 1.875. Not sure if anybody can do that one in their head or not. But yeah, and so our final answer would be that it takes 1.875 hours to mow the lawn if they work together and have 2 mowers. So this one's a little bit different. So now we have 2 intake pipes to a large storage tank. Using the smaller pipe alone, it takes twice as long to fill the tank as it does using the larger one alone. The tank can be filled in 8 minutes if both of the pipes are used. And we want to know how long it would take using only the small pipe. So let's have L be the time in minutes it would take using the large pipe alone. Then we know that it takes twice as long using the smaller pipe alone, so it would just be 2L for that one. So, and we're going to make everybody's favorite. I know you guys really miss these tables. So for the larger pipe, the work rate is going to be, oh gosh, and I switched my variables here. Sorry about that. I was using L and now I've got X's here. So the work rate is going to be 1 over L. The time is going to be 8 minutes because we want to know how long or how much will be filled in 8 minutes. And then the work done, we just multiply the rate times the time to find out the work. And similarly for the small pipe, but instead for that one, for our work rate, we're going to have 1 over 2L or 1 over 2X if you're looking at my screen. Time again is 8, and work done, we're just going to multiply the rate times the time to get 8 over 2L. So then if we take that table and we fill in the larger pipe plus the smaller pipe equals the whole tank. So we've got 8 over L plus 8 over 2L equals to 1. Now we do have our variables in the denominator. So our LCD is going to have a variable in it. In this case, it's 2L. So when you multiply that through on the left-hand side, we're going to get 16 plus 8 equals 2L. And then we can just combine those numbers on the left. We get that 24 equals 2L and L equals 12. So what that's telling us is that it would take the smaller pipe 24 minutes to fill the whole tank, because that L equals 12 means that it would take the large pipe 12 minutes, and we know that the smaller pipe takes twice as long, so it must take the smaller pipe 24 minutes to fill that whole tank up, which we actually didn't even really need to find L here since our equation already gave us 2L, but it's still kind of nice to know and be able to check that. Okay. So our next example says that Robbie can seed his garden in 4 hours. Working together, Schmidt and Cece do the same job in 1.5 hours. How long would it take Cece to plant all the seed alone? So I'm going to pause again so that you guys can get this one set up, and then we'll go through the steps. Oh, and I'll give you a hint, there should be a table here. Alright, so this time I chose to use S for my variable. So that's the time in hours that it takes Cece to plant the seed all alone. So when I set up my table, I end up with that the work rate for Robbie is 1/4 because it takes him 4 hours to do the whole thing. So I take the reciprocal of that. And we know that the time is 1.5 hours and that the work done is just going to be the product of those two numbers. And then for Schmidt, instead of 4 hours, because we don't know how long it will be, we're going to use S hours. And then the time is going to be 1.5 again, and work done will be 1.5 over S, that product there. So we multiplied by our least common denominator, which in this case is 4S. So when we do that on the left-hand side, we just end up with 1.5S because the 4's cancel out. And then 1.5 the times 4 because our S's cancel out, we get 6. And that is all equal to 4S times 1, which is just 4S. So we can subtract 1.5S from both sides. We end up with S equals 2.4. So it would take 2.4 hours for Cece to plant the seed all alone. All right, and that is it for you guys. This one's a pretty short section. So for your assignment, you guys are going to do page 445 through 446, numbers 2 through 14 even. And like always, if you have any questions, feel free to walk over and ask Mrs. Lucier. I am sure she would be happy to explain whatever you guys need. Hope you're all having a great day.